Hello, everyone. I'm Fernanda. I'm going to talk to you today about liposomes. I want to mention that my project is in cooperation with Evonik, ILL, and the Technische Universität Berlin. So let's start. And why are we interested in liposomes? Well, we can see a small scheme here of what is a liposome. Basically, they have a close resemblance to the cell membrane structure, and they're an established delivery form in pharmacology and cosmetics. And basically, there are these hollow spheres that if we zoom in, we have if we zoom in, we can see that it's composed by a phospholipid bilayer. And if we zoom in even more, we see the building unit of this bilayer, which is of course the phospholipid, which is an amphiphilic, meaning that it has a hydrophilic head and a hydrophobic tail. So what we want in industry is to have stable and functional liposome formulations. And to achieve this, we need to know what are the influence of additives. So what if we mix several lipids in our formulations? And also what is the influence of the solvent in these lipids? So this elucidation is required. In the case of the additives, we ask ourselves, what if we have our building unit that is a phospholipid and we add something else, a surfactant, another lipid, let's say lysolipid, which the main difference in comparison to the phospholipid is that it only has one alkyl chain. So what is the influence in the encapsulation properties of our liposomes? And on the other hand, we ask ourselves the influence of the solvent quality. So what happens to the bilayers when they are in alcoholic solutions? And this is of interest because of the method of preparation in industry, which is very oftenly used the ethanol injection method. So we do need to know what is the role of the alcohol playing with the self-assembly. So as I mentioned before, the bilayer is composed of several phospholipids that self-assemble, meaning that it's not leak-proof. There's going to be some diffusion between the core of the liposome to the outside, to the bulk solution where the liposome is found. So if we add the lysolipid, which is another surfactant, we can see, and even at really small amount, 0.058% or 0.1%, we can see that there is complete release of what we are tracking here, which is a fluorescent dye. There is complete release already at, let's say, 25 hours in comparison to the phospholipid dispersion, which already at 100 hours, there is not even more than 30% release. So what we know is there is a huge permeability increase, and we can therefore conclude from this that we can tune the barrier properties of the bilayer with different additives, such as different surfactants or different types of lipids. If we move to the second question, what happens, what are the interactions of the solvent with the liposomes? We can see if we study different type of phospholipids in an alcoholic solution with different ethanol content. With light scattering, we can see immediately that there is liposome size reduction. So we know from static and dynamic light scattering that we still have spherical shaped vesicles, liposomes. So we want to look even in more detail what is within these self-assemblies, and that's why we use small angle neutral scattering. So if we take this phospholipid, lipoides 100, which is a soybean lecithin phospholipid, if we take it and study it under SANS, we know that we have unilamellar vesicles, meaning with only one bilayer. We have spherical shaped particles, but we know that there is a thinning of the bilayer that is caused by the presence of the alcohol, and there is a change in the contrast variation. So it's possible that there is incorporation of the alcohol at the head group region, for example. If we take the same dispersion and we study it with neutron spin echo, we see there are different relaxation rates from the bilayers. And with this, what we can study is actually the bending rigidity of the bilayer. So we know that the more alcohol we add, the lower will be the bending modulus of the liposome. And this is in agreement with what we saw from SANS, because since we have a thinner bilayer, of course, the energy input needed to bend this membrane will be lower. So basically, we also have a membrane softening. So what I want for you to take away today is that it's possible to tune the barrier properties of our liposomes through different dispersions, and that the solvent composition has a direct influence in the structural arrangement of lipids, as studied as neutron scattering techniques for now, hopefully next year, also with X-rays. The outlook will be to study more complex lipid formulations because this is, of course, something that has been simplified. And in industry, of course, we have a lot of different additives and phospholipids, and to elucidate whether short-chain alcohols really act as co-solvents or co-surfactants. With this, I want to thank you for your attention.